Hey, well, good afternoon, everyone. I'd like to welcome you to our seminar series. So the Temerity Center for AI Research and Education in Medicine. So before we start, we have a few housekeeping items to take care of. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. With respect to T-CAIREM, so the Temerity Center for AI Research and Education in Medicine at the University of Toronto has been made possible by the generous donation from the Temerity family. T-CAIREM is an interdepartmental center that serves as a focal point for collaboration among healthcare providers, trainees, researchers, computer scientists, engineers, and industry. Our goal is to transform health through AI. Quick mention, this event is CPD accredited. To obtain your CPD credit, please use the QR code that will show on the screen at the end and complete the evaluation form. We would request that you use the Q&A function in Zoom to submit your questions for today's speaker. He will address them during the discussion portion of this webinar. By attending this event, you're consenting to being photographed or recorded for non-commercial use by T-CAIREM. So now it's my pleasure to welcome Derek Beaton. So Derek Beaton leads the Advanced Analytics team in Data Science and Advanced Analytics at Unity Health Toronto. Over the past 7+ years, his team has deployed more than 50 data science tools into practice across Unity's hospitals. These range from staffing solutions like assignment or scheduling to operational, such as ED department wait times or volume forecasting, through to clinical tools such as CHARTWatch, a deterioration prediction tool, and a suite of real-time medical imaging tools. The Advanced Analytics team also evaluates and monitors the performance and impact of the tools that DSAA creates. Derek has authored or co-authored over 60 journal publications and is currently the joint world records holder for the fastest 5% costumed half marathon and fastest 5-person costumed marathon. So it's my pleasure to ask Derek to start his presentation, and we'll have this presentation until around 12:45, following which we'll have a question period. So please, as I mentioned earlier, put those interesting questions in the chat, and we'll be happy to, Derek will be happy to answer them at the end. So on to you, Derek.
Wonderful. Thank you so much. Let me get this sorted. All right. I think we look good. Okay. All right. Thank you for having me. I'm Derek, the Director of Advanced Analytics. I really appreciate the warm introduction. So I'll just dive right in and tell us a bit about how to build, or how we build and have rebuilt our platforms for applied AI. To start out, no disclosures or conflicts. And I'd like to begin by describing what is AI, or what is the definition of AI we're going to use today, or some of the bases of these. Some of the earliest definitions that we use for today are based off of the concepts and understanding that we have of computing. And the earliest bits and pieces, some of the fundamental parts, go back to the 1940s. The first kind of artificial neuron was introduced. And then the definitions of what we think of as AI today really developed in the early to mid 50s through works by Alan Turing and the Dartmouth Workshop. But for today's definition, we can think of a Venn diagram kind of like this. We typically see these Venn diagrams floating around a lot, where there's this interrelationship between deep learning, machine learning, AI, and you might see a whole bunch of these around. And I've stolen this slide from Martin Van Smieden's slide deck, Rage Against the Machine Learning, because it does help illustrate that a lot of these terms, fields, domains are a lot of the same things, or based on a lot of the same things. And it's all about making this practical. Sometimes when we think about the definitions of AI, it is driven by what's popular. We can think back to connectionism and parallel distributed processing, moving all the way up through technologies that we see today, like transformers, or thinking about interactive voice response tools, like when you call a company on the phone, or generative AI. It can, in fact, be driven a lot by what we are successful at, what is popular, and what is really driving a lot of interest or a lot of practical ability. This is one of my favorite tweets because it does help show just how related and interrelated all of these fields are, and how the fundamental basis of all this stuff has been around for a while. This was a pretty good tweet, showed some work from 1965, and I got really excited when I first saw this because that graph is by an author who, quote, did a lot of obscure French statistical methods, created a lot of obscure French statistical methods in the 1960s. And I based most of my dissertation on that. But really, the fundamental basis of what was done in the 60s is actually still seen today in many of the tools like ChatGPT or transformers for when we're trying to understand how things are working together or co-occurring together. So I'd like to set the stage with a practical definition, and I'm just going to steal another tweet from Daniela Witten, a biostatistician, where AI is a software wrapper around machine learning. Machine learning is a fancy word for statistics. So this is in part facetious, but in part has a really good basis of what it means to actually take something very practical and make use out of it. So for us, we'll operate under these criteria for today. We're going to have a lot of data. We need to make a model or an algorithm of some sort. We need to build software around that model. We're going to put that model inside the software somewhere, and its point or purpose of the software and the model or algorithm together is to guess, guide, group, or categorize new data that come in to make sense of it. More importantly, we need to make those outputs or whatever goes in and comes back out useful and actionable. And that is basically the practical definition that we're going to operate from today for applied AI. So the outline for today, story in 3 acts, and there's a partial cliffhanger here. I'll tell us a little bit about the data science and advanced analytics team. Then I'll move into the tools, environments, and a number of the lessons learned, which reflect our journey on building an environment for this. And then partially conclude, with what a massive digital transformation is and means. And this is basically about 2 months ago, we transitioned from a bunch of other source systems in our hospitals to Epic. So this transition has basically required us to rebuild a number of things that we do and take the opportunity to look at newer, modern ways of doing things. But spoiling a bit of the end, we're only 2 months in, so there's a little bit more of a rebuild to go. So who are we and what do we do? The Data Science and Advanced Analytics team is a team that is situated at Unity Health. Unity Health is 3 hospitals in the city here. So on the west side, we have St. Joe's. Right here in downtown, we have St. Mike's. On the east side, we have Providence. The DSAA team is part of a strategic pillar at Unity Health. AI is one of the core strategies of this organization. And we are a team of only 30 people. And our goal, our purpose is to develop tools that will help people make better decisions or increase efficiency or improve patient care. And we've done this with, over our whole span, more than 50 solutions. We're structured in a way where we have little sub-teams. Each of these teams play an important role, especially as we build and rebuild our environment. So I'm part of the analytics team. Our team will handle the modeling, model development, and a lot of the statistical evaluation of our tools after we put them into production and into people's hands. The data team or data integration team largely is an infrastructure team, data engineering team, and ways in which we are able to access different source systems and run our environments. The product team is primarily a software development and design team. They will find ways to build tools to help bring our models to people or ways to integrate with existing tools like EPRs. Finally, or almost finally, there's a support team with product managers and clinical informatics specialists to help us understand the workflow and drive the way our products are built and deployed. And then actually, finally, we have a team of commercialization. It's 1 person right now, where the role of the commercialization team is to build more relationships with industry, other organizations, and to help see a number of our tools that we build inside our walls make it somewhere beyond our walls. So I'd like to tell us a little bit about some of our deployments, but I'm going to start very high level with a slightly outdated view of all of our deployments. What we see here is a picture of almost everything that we've done in the past number of years, where on the earlier side, by the 2018 part, these are the beginning points of a number of these tools. And as we get over to 2024, you'll see another dot. All of these other dots are indicative of a deployment or redeployment of a number of these tools. And what we don't really have here, but we'll see a little bit of this story as it develops today. These lines go off the screen for many, many, many of these because once you deploy or create a product, you need to maintain it or update it and make sure that if something is working and people like it, it needs to run, needs to stay online and continue to make the impact that it does. So these tools reflect a variety of the ways things can work for when you deploy a tool. We have things that will work every week, every day, every hour, 15 minutes, less than a minute, or in real time. We're going to see some of these much more concretely soon. And we cover a whole range of solutions. We're not specialized in just one or a few different departments or roles or types of data science and AI, but almost any type of problem where there is data and we need a solution. And this will cover clinical tools, workforce and staffing tools, operational, and some of our latest work is specifically in imaging. So a bit of a spoiler for part 3. As I've indicated, we've made a transition from older source systems across all 3 sites to Epic, a brand new electronic medical record system just 2 months ago. So a lot of the tools that you just saw have been turned off temporarily. But you are some of the first to hear that some of these are actually back in a preliminary or testing stage, which I'm going to discuss a lot more at the end. I'm going to highlight a few items today. Right up front here, this will be CHARTWatch, a deterioration prediction tool, hemodialysis readmission prediction for high-risk patients, and then a suite of tools out of the emergency department and radiology. There will be a few more tools that appear later in this story, but I'm only going to bring them in as necessary to help reflect how we build or rebuild what we do. So CHARTWatch is a tool that on the hour will make a prediction for all patients in general internal medicine unit if they're likely to go to the ICU or die, a deterioration tool. Initially, we deployed this in October 2020 in general internal medicine at St. Mike's, but have since scaled this to other units at St. Mike's and down the street to general internal medicine at St. Joe's. A lot of the effort now has been spun out and is led by a company, Signal One, that we work very closely with. And we've recently published a study on the impact of CHARTWatch in the general internal medicine unit. CHARTWatch from pre to post deployment has shown approximately 26% drop in mortality rates. So a tool that is both accurate and making an impact, considerable impact once it was deployed. The hemodialysis unplanned readmission prediction tool is a weekly tool that will generate risk scores for all hemodialysis patients. And the point of this is to help highlight those that are at highest risk of coming back to the emergency department after a dialysis session. This was deployed in July 2022 and has shown a substantial reduction in unplanned admissions. This is a visualization of what users will see. Every week on Sunday, they will receive an email that has a list of patients, what kind of risk group they are in, previous risk assessment, and a little bit of information on the last admission and admission types. This tool, like many other tools we have, isn't just a tool, but it is paired with an intervention. And there's a care pathway, intervention care pathway here that focuses particularly on high-risk patients to ensure that, or help ensure that patients that are at high risk of readmission ultimately do not come back to the ED for some unplanned reason. So moving on, speaking of the ED, we have a number of tools in the emergency department based on imaging. And these are largely for cross-departmental situational awareness and communication. The core element of that is something called the Emergency Department Radiology Tracking Board. This is a static image of it. We're going to see an animated version of it in just a moment. But this helps tell multiple people across multiple departments what's happening. The top part of this screen is a reflection of all images that have been ordered. The bottom part of the ED radiology tracking board are all the images waiting for reads, and then a bunch of other information to help us understand the patient journey along the way. In addition to that, we have two AI models so far that have been deployed. Intracranial hemorrhage detection, which will identify the location and type of a bleed in the brain, and a traumatic brain injury tool, where it flags images or patients that are at high risk for urgent neurosurgical intervention. And both of these models run on all non-contrast head CTs that come into the department and will have end of image to an alert in under 3 minutes. And this is an animated version of what you should or could expect to see. And we're about to see a little blue icon pop up that is the flag for the intracranial hemorrhage detection tool. So this is a screen that is seen by a lot of different people in a lot of different places. And when these little indicators come up, it is a broader awareness of something that likely requires more immediate attention. So how do we do what we do? And what are some of the lessons we've learned along the way that we can share with others as they are also on this journey? I'm going to first talk about the tools and technology that we use. At its core, I do want to say that the way in which we build our environment is people. The creativity of those that are on a team like ours and people that want to solve these types of problems really do get us to where we are today. And what I'm presenting works for us at our organization. If you're on this journey yourselves, I do ask that you just ask around. There are a lot of different ways to build environments to do this. And kind of frankly, not a lot of information is shared quite yet on exactly how to do this at scale. So I do encourage everyone here to ask anyone else, any other organization, how do you do what you do when it comes to any sort of applied work? So the way we do things, to start at the kind of physical and core infrastructure aspect, is that we are currently entirely on-premise or on-prem. And as part of our data team, we have a little mini IT team. Their role is to largely help manage the tools, the physical assets like the servers we have. And we have a lot of development power at our disposal. A number of heavy-duty servers, machines with GPUs, a lot of CPUs and memory, so that we can build the models that we build or develop any tools that we need to. In addition to that, we sort of co-own or co-manage a number of our production servers or infrastructure with IT. And this is because these systems will either connect to or are sitting very close to other production systems. So this is something that is to a degree shared, or we have line of sight into what we are doing with IT. There are just a handful of things that are at the core of our data infrastructure. This isn't everything, but this really is several large pieces. For a number of our data sources, we are using CData as data virtuality tool. This is something that sits on top of many, many other tools and allows for integration of many sources from a number of places. So most of our clinical data from multiple source systems, workforce data, or any other type of tabular data will really come into data virtuality for us to have a convenient singular landing zone to access this. Our imaging infrastructure is based primarily on two pieces of technology. One is called XNAT. XNAT is, for us, largely a historical archive tool. You can think of this as a research type PACS or archive. And OrthThank, which we primarily use for our real-time deployments. And underneath all these tools, and we use separately, and it's just kind of everywhere, is something called Postgres. It is a workhorse for a lot of what we do and how we make sure things get done. So data is not just about tools, platforms. We do work very closely with a lot of other teams. These are clinical teams, IT teams, other clinical informatics specialists, to make sure that we know what the data are, where they come from, the frequency, the quality. And in a number of cases, we will use different technologies in the hospital, like accessing a backup system instead of the primary system for our images when it comes to PACS. We also have access to a number of data warehouses where there's archives for us to build and train our models. And we do thorough testing with a number of other teams for how we deploy these things because we are, in some cases, hitting production level systems. And we'll do that in a variety of ways to help ensure that we get what we need, but we don't pressure anything, don't pressure any other systems by deploying our tools. Our development is fairly straightforward. Standard software and data science tools. We rely heavily on POSIT, formerly known as RStudio, for development, library management, and deployment tools. That is Workbench, Package Manager, and Connect, respectively. And then a lot of our work is in standard development environments. We rely heavily on R, Python, React.js, and SQL. We try to integrate where we can. And this is really a place where the product development design team, the clinical informatics specialists play a pretty big role. We try to get our tools back to where people are, but sometimes we can't. And when we can't, we need to find ways that are companion ways or something that will not be disruptive, something that helps people with a new tool that may be in a new spot. When we cannot actually put something back into where they already are in their workflows, like a patient record system. So the big thing around this is that solving these problems, having an environment, is not just creating a model. And I want to take us through the journey, a little bit of a journey of how some of this stuff was built and the interesting things we've seen along the way for the three of the tools I just told us about. That's CHARTWatch, hemodialysis, and the intracranial hemorrhage detection tool. Starting with CHARTWatch. Quite some time ago, it was our first big go at pulling directly from source systems. And this does require hitting a system quite frequently. And this helped lead us to data virtualization. There are ways in which these types of tools will sit above other production systems to make sure that the burden of getting data is actually minimized or in some cases removed. In the earliest days, a lot of the demos and testing of CHARTWatch was running off a laptop well before we got into full production on our production level servers. We learned lessons to have service accounts, don't use individual accounts, never link something to an actual person, have something that is more organizational. We had some stumbling blocks where we were using file-backed ways to approach this, and some research drives, network drives, are actually subject to frequent downtimes and would disrupt CHARTWatch, and we'd get a call in the middle of the night or on the weekends to go back and fix this. And something that helped push us towards our POSIT tools was we needed this to be scheduled, and we didn't want to have to build a lot of this stuff on our own, and we sought out tools that could help us do this for us. Hemodialysis presented a number of very interesting challenges for us. Functionally, it was integrating a bunch of different systems, the primary patient record or medical record system with data warehouses, other sources, and frankly, kind of a specialized EMR that is for the dialysis machine. That had a number of limitations on it that included really only accessing it on Sundays, which kind of drove part of how we deployed this, and really very particular things that it only worked in some cases with certain types of machines. But after a couple of years, we chipped away at it to make sure that it fit into the same kind of framework that we use for most, if not all, of our deployments. And then finally, the intracranial hemorrhage detection tool was something that had so many roadblocks that we threw up our hands and said, we're just going to build a real-time deployment platform ourselves. So a very high-level snapshot of this is basically a complex interaction between a number of different systems where we used a whole bunch of new technologies like NICs for reproducibility, distribution across GPUs and multiple servers, containerizing our applications, and really leaning into monitoring of systems. And this is going to come back up later. So this was such a fascinating case where it was so difficult to try to get the model where we wanted and the ways we wanted that we just kind of built something from the ground up all by ourselves. I don't always recommend that. If you can buy. If you have to build. So some of the lessons we've learned along the way from deploying these tools span a number of different topics. I'm going to start out with some technology and platform lessons learned. We just saw this a little bit with three of the tools that I mentioned. One of the lessons here is just get in there and try something. There will be failures, there will be challenges, there will be roadblocks, and it will require the creativity to solve these problems and searching out for other solutions on how to actually make these things real. Which brings us to some statistical modeling and evaluation lessons that we've learned over time. So with CHARTWatch, we had historical data to build the model, and that's everything on one side of this blue line. And then we launched the model, put it into deployment so that people were using it sometime after October 2020. When we take these data, we typically in model development and algorithm creation label our data in one way or another. And for CHARTWatch, we had deterioration versus no deterioration. But once we deploy something, this deployment comes with an alert. That alert is paired with an intervention. So when we have deterioration and no deterioration, or alert and no alert, we can think of these cases as a possible configuration of true and false, positives and negatives. But as CHARTWatch has shown us, there's actually a secret hidden category. If there is, in fact, an alert and an intervention where deterioration is potentially prevented, this would have been a true positive, but in the future, or when you're monitoring for performance, it looks like it's not because you have, in fact, prevented a deterioration from happening. And this does have consequences in a couple of ways for how to think about what you're doing and how you're monitoring some of these things. So any intervention-based workflow could or would result in potential label changes. You're going to have some fuzziness once you actually introduce any type of intervention, not just an AI type intervention. When it comes to monitoring, we do know that there should be some level of performance drop simply just because the labels don't quite match the expectation. And there are future consequences. Retraining would actually be a little bit more difficult. We'll have to account for some of the fuzziness there, or training of new models, which brings us to this case. So we introduced another model later on called Reward AI. It's a bleed alert tool that runs daily. And CHARTWatch and Reward AI run on the same patients in the general internal medicine unit and largely has the same user base. And they both have different ways of actually getting this information back to users. And this is an expanded version of the timeline of what it looked like. So we can see that there were data that overlapped from Reward AI to CHARTWatch. And this is why these stages here are critically important. We have something called a silent deployment, which is an important part of how you actually put these things into production. We use silent deployment to make sure everything is okay. Everything looks right technically, everything looks right statistically, everything looks right clinically. And once we get past that stage, we can put something into deployment. So for us, we were fortunate where everything from the training data, everything we expect from Reward AI looked good and we could deploy. But we introduced a different problem for ourselves that we're investigating right now. It's pretty fascinating. Which models may lead to an intervention? Do we have any sort of conflict or adherence problems? There can, in fact, be a perception problem if users are receiving two alerts and they've already intervened through one tool or another. And there is some pretty good work out there that has started this in simulations, but we're starting for ourselves now to really investigate this and understand how much of an impact could co-alerting models or both models running in the same place with the same users, what kind of impact will that really have? Now, from a technical and design perspective, we've also learned lessons coming out of there. When you have multiple models, but the same users, and these are running on the same patients, there is a potential to increase cognitive load. So how do we learn a lesson from there and design something different? Well, that is, in fact, a lesson we've learned and taken over to the Emergency Department Radiology Tracking Board. This is a centralized tool. All images, all patients that are getting imaging are up on this board, and all the models right now, only two, will be in one spot. You don't have to go to multiple places to actually get these alerts. So this is a consolidation of information in one place that makes it a little bit easier for users of these tools. So the different types of tools we have also shown really interesting problems for us in understanding when something is working or not working and what we have to do or when we have to respond. And I'd like to highlight the big gap between event-driven and scheduled tools. So something like Reward AI runs on a schedule. If we don't see an email or if the users don't see an email at 10 a.m., they know something's wrong. They'll call us, they'll call IT, we'll start acting if we don't see something. We just know something is up at 10 a.m. if we don't see this email. When it comes to an event-driven tool, like intracranial hemorrhage detection, we don't know. Is it because there is no bleed? Did the model fail? Imaging not complete? Is there something wrong with the packs? Not sure. So this has brought us in our environment building phase to very sophisticated and comprehensive monitoring. We've taken monitoring pretty far on the health and integrity of our systems, our models, but we're also monitoring for absence of things. For example, if we don't see an image come into the ED in 30 minutes, or if we don't have a certain HL7 message that passes our way, or if we haven't sent an alert out at a frequency we would expect from historical data, we send ourselves little alerts to look into things. And this is a way in which we've actually uncovered a number of issues or kind of gotten a heads up on upcoming downtimes when something was a little bit off. So this brings us to part 3 for today. Preparing for and rebuilding around a massive digital transformation. So what is a massive digital transformation? Well, about 2 months ago, we migrated to Epic. November 30th, 2024 at 4 a.m. This date and time has been drilled into our heads. And we are currently in a stabilization period. This is projected through to the end of March, give or take some time for certain technical things to work out and certain workflow things to get situated. And prior to this, all 3 sites at Unity were different technologies, different systems. And this was a considerable challenge for a lot of people, and in particular, our team. So for example, we built an emergency department volume forecasting tool at St. Mike's. We wanted to bring it down to St. Joe's, and it was basically a complete rebuild. We're using different systems, different flow. It was basically like building the same tool twice. So we are very much looking forward to what this harmonization on a modern EPR is going to give us someday. We're 2 months in. We can see it, but we're not quite there yet, but we do expect to be there pretty soon, where we can watch the scale of tools we develop in one site or for one department go across the whole organization where and when relevant. So what has happened to a lot of the DSAA tools in this process? I spoiled a little bit of this. A number of them have been taken offline. Any tool that required EMR, EPR data really had to come offline. There was a big change here. Data changes, data is fresh. You're kind of starting from scratch at that 4 a.m. line. 3:59 to 4:01 a.m. was just like a whole different world. But there are a number of other tools that have stayed online. And I do want to highlight this because it's an important anchor for how we've built and how we are going to rebuild in the future. We have a particular tool working in our emergency department for RN assignment. This will create optimal and fair assignments for RNs to different zones in the ED. It accounts for qualifications, previous assignments, and before this tool, it took a long time for individuals to create an assignment. And there would be frequent repeat rates. So the same person getting assigned with the same colleagues or into the same zones over and over again. Now with this tool, repeat rates have plummeted, and it saves about 45 days out of each year just by using the tool. And it is a nice tool that will show you where everyone should be assigned, and it works fairly instantly. So why am I highlighting this one in particular for something that's been around for so long? We kind of affectionately refer to this one now as pandemic proof. It's one of our only tools that really was developed before the pandemic started and has lasted well beyond, and is still used to this day. The core of the problem itself is a very good one. Assignment isn't going to go away. For us, from a technical perspective, it was built and designed really well. And as an exemplar case for what we've done for a solution and a product, we're using a lot of the lessons we learned and on the ways we built this tool to inform the way we're building tools going forward, especially for a number of the tools that have come offline and will come back online. Now, there are other tools where we're going to embrace the new. So what does that mean? We had a model built, a vascular surgery risk prediction tool that we didn't get into production in time. We were prepared mostly, but we were getting really close and decided we don't want to put this in. It's a little bit of a risk. It's going to be a headache for everybody. Let's pause and wait until we've actually made the transition to Epic and then try to get it into Epic later. Or actually, just try to deploy this later. through the journey of understanding Epic and data flows and planning for this a long time ago, we wanted to take a chance at exploring alternate ways of deploying models. So for this model in particular, we're using it as kind of the flagship case to explore how to deploy models directly into the EPR. And we're looking right now at PMML, which is a markup language for directly putting a somewhat simple model directly into the EPR and effectively directly into someone's workflow. But we are also considering sometime not too far into the future, the cloud offerings and more advanced ways of deploying models through the Nebula feature in Epic. And why we're doing this is we're hoping that we can reduce some of our maintenance burdens, going all the way back to all our deployments, all those lines that go off the screen, because we are in a maintenance phase for everything that we build. If there is a way in which we can reduce some of the maintenance burden, we're going to take that. And we do think some of the new tools, the more modern EPRs, are actually going to afford us some of this reduced burden and allow us to put maybe more models in certain places in certain ways while we spend our maintenance and development time on the more advanced types of platforms, techniques, and approaches. So speaking of which, we are also doing a whole lot more. In this time, we are adopting other technologies, more modern technologies from software development and AI production tools. We are really leaning into orchestration, more containers and infrastructure as code to really, really simplify our lives and hopefully eliminate a lot of maintenance burden and allow us to scale. Now, more importantly, we're also building out for the future. We're in the very early phases of capturing waveform data, and we're exploring ways to get ourselves off of on-prem in a hybrid way. We are particularly interested in hybrid cloud on-prem because we know a little bit of the ups and downs of each, where we'd like to leverage the best resource at the best time. And whether that's some of our GPU servers for inference or training or burst into the cloud for something to scale, we'd like that to be our future. And we're starting that journey right now. So that is a look a little bit ahead. What are we doing right in this very moment? We have outlined a number of trust and safety measures for the tools that we're going to bring back online. So there's a kind of natural order here. Our imaging tools are relatively unaffected by the imaging systems, I should say. But we do wait for particular messages from the EMR. So these ones are kind of nice, where we don't need to check much. We need to just make sure we're getting the right things. We can go off to the imaging system, get what we need. This is a relatively fast-ish series of checks for us to make sure that everything is working as expected. The next level are some of our operational tools, like emergency department wait times. These don't require all that much data by comparison, and the ways in which we built the models, we know how to check these fairly quickly. So some of these tools have a relatively fast way or not so slow way of getting back into production, but there are more complex ones like CHARTWatch and hemodialysis that require a lot more effort and a lot more to consider, which I'm going to show us in just a moment. So how do we actually get there? Well, we start with the data. Right now, we're 2 months past this transition. Some technical issues are there, some workflow issues are there. And if we just start putting data into a model, we might kind of be wasting our time. If you put bad data into a model, you're going to get bad information out of it. So we've leaned very, very heavily into data validation for comparing pre-go live data to post-go live data. And we're leaning on a number of different tools, techniques, and approaches that I'm just going to jump right in and show us. So there's a great set of tools out there in both R and Python for validation of data. For those of you that are familiar with software, this is almost like a unit test, but for data. We are actually ingesting all of these data elements, making sure that the ranges are correct, the types are correct. If there are multiple levels or categories, that we're getting what we expect, the schemas, the database tables themselves, we're able to test and check for any failures to then immediately go and ask, Why are we seeing a CTAS of 6 or -1? Is there something wrong here? We're also using fairly classical approaches like control charts, where we can see data coming in. If anything violates these red lines, we know that they are out of an expected range. And these red lines are in particular taken from hemodialysis, where we have both historical information and clinical information shared with us on what the expected ranges are. So this is a nice way for us to check when something is being violated in terms of data that's coming into us. And finally, very creative approach that the analytics team came up with right before we went live was to use quantiles, pre versus post. And instead of describing this, I'm going to show everybody here something that I only saw the other day and I am particularly excited about. So you are the first people to see this in action. So we are making use of pre versus post go live data at the quantile level, because you can't match patient to patient or anything like that, to get a sense of how these fundamental data for a lot of our models actually look. And I'm highlighting one here that is fantastic. Sodium looks almost exactly as we expect. The violin and box and whisker plots look really good. This quantile plot is looking pretty good. Not many complaints. But this approach has really helped us identify a number of cases that are really useful to prepare for or act on. So this one is particularly interesting because the quantile plot kind of looks like it's on a nice diagonal and very friendly. But when you look at the box or violin plots, we see one is squished and one is stretched. And what we've uncovered here is what we believe, we are verifying, a unit change. And this is something we anticipated quite a while ago. The simple thing here is if you think of, say, temperature, Celsius, Fahrenheit, there's a formula. If we know the units for pre, we know the units for post, we can use a formula and just transform these data to make sure they go into the model as expected. Because if we put them in like this, the values would look way too high and potentially lead to incorrect model calls. We're also seeing something like this with a slight shift in certain measures where post-epic data are a little bit off. There's kind of a nice diagonal, but it's lower than what we expected. Something like this requires us to dig in. We talk to app specialists, clinical people, and also just verify that we are, in fact, mapping these things correctly. But my favorite one so far is that we have found cases where something is just wrong. In the prior 3 that I've shown you, all of these can't be handled. They either look good or we know what to do to get them into a model and we know how to handle that. This is a case where we wouldn't. This is something that is a little alarm bell for ourselves, just like the monitoring alarm bells I told us about before, where we act, we follow up with different teams, we check to make sure we're actually comparing the right things, we find out what was actually happening. And this is a really good example of something that just shouldn't go into a model, and we're able to catch this way before we're ready for that. So my advice so far, 2 months in, which I think is paying off for us, is waste no time in these types of massive changes. In these very big, huge transitions, you don't have to wait for your data. You don't have to wait for a lot of the dust to settle to find out if your models still work. You can chase a lot of things down almost instantly and get ahead of that so that you'll save a lot more time and effort trying to figure out why a model might be wrong when at the source, it was something up with the data. So where does this all lead us? There's a really interesting future for what we're going to do. You've seen now a very, very comprehensive approach to data monitoring, and we are going to lean into that pretty hard. Where that will lead us, and in all transparency, I don't know exactly what the answer is here. Are decisions on when to not generate a prediction. So if we have, say, a handful of data elements that are coming in for a production tool, if they're outside of expected ranges or they are somehow bogus or incorrect, there may be instances where we should put a pause on a model. Instead of having it make a bad call or wrong call, we just say, stop the model run and inform the users that there's something here that we've decided where we do not want to run the model. some of the data don't look good enough or to expectations, where we think it's better to tell you that we shouldn't run the model as opposed to generating a model result. We're seeing this in a number of different cases, and we're trying to figure this out for a lot of our tools. In cases like imaging, it's a little easier. For things like a lot of the clinical systems, a little harder. What is that threshold? Is it 5% of data, 10%, 50%? How far out of range do you need to be? How much missingness can you accept? We don't know yet. But we think that this is an important part of future for how we monitor what we have and how we deliver results back to people. So what can I tell you about all of this? I told you pretty much everything. We're 2 months in. And I would really appreciate it if you check on us, see how we're doing technically, maybe emotionally, in a month, 3, 6, or 12, to see where we're at. In all candidness and transparency, a lot of this planning that we had put in for about a good year, maybe over a year, has really paid off with what you just saw in the data validation. This is a fairly extraordinary thing that we were not entirely sure if it's going to work the way we expected. And we are pretty delighted to see that we're able to catch these problems well in advance. So yeah, please check in on us and see how we're doing and what kinds of lessons we can teach you a few months from now. So with that, I'm going to start with some acknowledgements and thank yous, and this is a long stretch here. So first and foremost, I'm going to thank a lot of other hospitals and a lot of people on this call across the GTA, Canada, and the US. In preparing for our transition to Epic, we spoke to a lot of organizations that were very, very generous with their time and very thoughtful with the discussions. This really helped us significantly for preparing how us as a data science team can prepare ourselves and get ready and bring our tools back to people as quickly as possible and safely as possible. Now, I'm also going to highlight, but I'm not going to read every name here. For all of our deployments, it takes an extraordinary effort. This truly is community organizational level. So CHARTWatch here has a whole bunch of people that need to be thanked, and I know, and I'm sorry for it, I'm missing some people. I deeply apologize, but I do want to highlight that every single tool we have, every deployment truly takes concerted and massive effort from a lot of people that want to make sure we get good and promising tools into people's hands that work effectively to help us improve efficiency, improve patient care, and help make better decisions. So with that, I want to thank all of DSAA, thank all of you for having me here, and I will take any questions.
Okay, great. Well, thank you so much, Derek. That was really, really an inspiring, excellent presentation. And I'm sure a lot of people, have learned lessons from your experience, your extensive experience in operationalizing the deployment of AI tools. So thank you so much for sharing that with us.
Yeah.
We have some questions in the chat here. The first one is, how did the recent transition to Epic affect things? Did you work closely with their team or using their dashboards or making your own?
I'll try to unpack that as much as I can. Affected quite a bit. We saw some of this. And we worked closely with a lot of people at Epic, a lot of people internally at Unity that were assigned to the transition. We don't really have dashboards. We build software around things. We may embed some of these tools into dashboards later, but we had started some conversations with dashboards and say the Cogito and reporting workbench team. And it didn't take very long for everyone to figure out like, oh, we are actually somewhere else. We need to be closer to different parts of the system. Oftentimes what you'd see for like source system to source system information, that's the kind of information we need and at the frequency. So we, after a few months, started a conversation with different folks at both Epic and within our own organization.
Okay, thank you. We'll move on to the next question. So for the deterioration alert tools such as CHARTWatch, have you found that there is a certain level of percentage of false positive and false negative alerts where users start losing confidence in the tool and stop paying careful attention to investigate each positive, or are constantly concerned that the tool is missing some pretty important cases?
No, I don't think so. And that is part of the actual development process. And if there's anyone here from some of the early days, maybe jump in the chat. The tool was designed with very particular thresholds that suited the needs of the users. So this was part of the development process, not something that came later. And we do actively monitor. We have, I think, a monthly implementation committee that goes over and reviews everything. This has been a tool that has worked for quite some time, but I would say fundamentally the performance metrics here were driven by and are based entirely on the development and close relationships with the intended users, as opposed to kind of playing with stuff after we deploy.
Okay, great. The next one is, can you share status and more specifics on your commercialization strategy and early successes?
I wish I could. I'm not the commercialization person. Please follow up with us. I would say one of the massive early successes here is CHARTWatch for bringing us together with Signal One. But please follow up with us. We can connect you with our commercialization folks to talk about the strategy.
Perfect. Okay, next question is from Navjot Bains. You mentioned aspects of silent production testing. Would you be able to expand on how you actually ran the test? For example, how long did you run it before deciding it was ready? How did you connect the model to real hospital data without affecting actual patient care? And finally, what were you looking for both technically and clinically before fully launching it?
Fantastic question. I'll maybe start at the last part there. Silent deployment for us really does have two silent phases. There is the technical, get all the bits and pieces up and running, make sure that we are receiving data, it goes into the model result comes out, it goes to some software endpoint or some custom built. We take over a largely technical view of that. We'll then start in with a little bit of a statistical view. If it is, say, hemodialysis readmission prediction, we're able to see if someone was readmitted 30 days later. So we're able to do some of that validation. But the more important part is early set of intended users that work closely with us as part of working groups to develop these tools. They'll do a clinical validation. Is this actually doing what you expect it to do? Is it correct? So there are really two phases, the technical and then the kind of gut. Is this doing what it's supposed to do? How long we do these completely depends on the tool. Something like hemodialysis runs every week. It's going to take a while. We need to know if it's going to run for several weeks in a row. Something like CHARTWatch, it runs every hour. You can see how frequently it would fail. This varies considerably for two reasons. One, technical. The frequency of which something happens will tell you like a failure rate or a problem. And then statistical. You need a sample size. You kind of need to know if this thing is working as intended before you hit the go button. The actual kick over that line is bring everybody back together, and it's go, no go. After a lot of comprehensive training and communications that happen well in advance to make sure that everyone is ready and prepared.
I'm just going to ask one question quickly before we continue. So I'm curious to know whether you have tried to implement deep machine learning tools like with longitudinal data, several variables, and whether you feel that those are more difficult to deploy as opposed to straightforward supervised ML models where you're just looking at a binary outcome. Because in my own experience, we have realized that some of those very computationally heavy models, we tried to deploy a transformer model, and we realized that it was very difficult to deploy via Epic, and we were not getting proper predictions. We were getting hallucinatory predictions, unusual predictions. So, and then we pared it down. So I wanted to ask your experience about your experience with this, and then whether you also use Shapley analysis for any of your AI tools to then inform individualized approaches or strategies for patients.
I'll start by showing a slide that I didn't show, uh, and then I'll speak directly to that. Yeah, so I had a hidden slide here. When it comes to methods, focus on what works. We got a surprising number of logistic regressions, penalized regressions, and XGBoost hiding. And we focus on what suits the problem. So yes, we do have a couple of deep learning tools. The imaging tools are deep learning.
The imaging ones, yeah.
Yes, because honestly, like that is a perfectly suited area for deep learning.
Yeah.
Anything else, go with what works and what is going to make an impact. So I'll like our ED wait times tool. It is a very simple forecast, like classical forecasting method. You don't really need much else. It works fairly well and is competitive against like fancier approaches. So to the point of the infrastructure, yeah, it is a little harder to actually maintain these more complex tools. We are fortunate enough where we have a couple of servers that we actually had to buy. We had a couple servers hanging around, but we had to buy some new servers to actually put the imaging tools into production. And this is where like we built a custom platform because couldn't put this anywhere. So we just did it ourselves. Now that does come with a significant maintenance and development burden, but we've done something really cool there. And it can be hard. I am a strong advocate of deploy what is a little easier to maintain or really what suits the problem. It also helps you in production. If something is going wrong, it's way easier to try to figure it out with an XGBoost or just a logistic regression than a deep learning tool that is harder to diagnose. We don't often rely on Shapley values. I don't know, I maybe have a hot take on explainability, but I think a lot of explainability approaches are mistaken for causality. Sometimes it doesn't really matter what these things are, just that something went wrong. And it will be hard, but those types of things are really for the data scientists, statisticians, ML folks to chase down and figure out, are the data coming in no good? Is something really wrong in the parameters here? But we don't rely heavily on explainability approaches.
Yeah, I find as a physician that it builds trust, at least among, and this is in the transplant setting, but I find it helps in terms of bringing trust in the prediction, especially when, say the top contributor to that prediction clinically makes sense. So I found it to be very helpful. But I agree. I mean, it depends on the problem. And I think particularly if you're looking at radiomics, then it may be difficult to really elicit what are the radiomic features that have led to that prediction, et cetera.
Yeah.
Yeah, thank you. So, okay, I'll take Matthew Komorowski's question next. So could you please elaborate on information governance, data security aspects between the hospital and the academic institution, as well as regulatory aspects? Are some of these tools regulated and approved, say by Health Canada, et cetera?
I might be able to answer both in one go. So it's not between an academic institution. We are an operational team. We live inside the hospital. We're not on the research side. So we are technically under the IT portfolio. And our initiatives are, we do leverage REB and QI. And because we build our own, these are for us. Regulation really comes into play when we're trying to like sell or push or give it to someone else. These are internal tools. And yeah, we are, sorry I didn't clarify this in the beginning, but the data science advanced analytics team is not a research team. We're a software shop. we're a fun little software shop that lives under the IT portfolio.
Okay, so I think we'll take one last question here from Jeff Gilchrist. So I know you're just getting started, but do you have an idea yet of how many of your current models you might be able to integrate into Epic using Nebula? Or do you think many solutions still require some kind of externally developed solution?
We got a little feel a while ago. So try to answer that in a couple ways. The tech stack in Nebula is actually more Python, and we have a ton of R. So we're not really able to bring them directly in. We just have to recreate them in a different language and put them in. Almost anything that is a kind of standard supervised ML regression type approaches, classification, we could probably put them in there. That's why we're dipping our toes in through that one model. Deep learning, absolutely not. For a couple of reasons. Honestly, one of them's cost. We've got some pretty great GPU servers. I don't think we should send our pretty heavy-duty models off somewhere else to the cloud and induce the cost when we've got it right here on site. Plus, that is potentially a large. It's not just a computational burden, but if you're sending a bunch of head CTs up to the cloud, like you might have a lot of data costs that actually come with that. So we did consider that. I don't think it's time for something like that yet, but we do see some candidates from our kind of like standard prediction tools that might be able to get into Nebula.
Actually, there's one really interesting question that I think I'll conclude with here. So you mentioned an effort to get these models outside the four walls of Unity. Any thoughts on how this moves to community hospitals where technical resources are limited?
Yes and no. So St. Joe's is more of a community hospital, and we have tried to bring stuff there, and we do recognize some of the challenges, both from the tech perspective and just very different populations. I feel like that question kind of bridges maybe some commercial stuff too. I'll have to say follow up with us. There are some things I can probably share about how we get across different sites and how it's honestly it's easier at St. Mike's, but now with Epic, this should get a lot easier. We should be able to bring things over in a faster way because of harmonized technology.
Okay. Okay, excellent. As you can see, there is a lot of interest because you had many questions here. I think we had a total of 20 questions here. So I'd encourage any of you whose questions we were unable to answer during the time frame to reach out to Derek. Is that okay, Derek?
Yeah, absolutely. Yeah. Please do.
Or perhaps you could answer some of those in the chat. So I'll leave it up to you. So I'd like to thank everyone for attending this fascinating talk. And once again, this is a CPD accredited talk. To obtain your CPD credit, please scan the QR code on the slide and complete the evaluation form. For all of the grad and post-grad trainees who are working on AI and medicine research, applications for the T-CAIREM trainee rounds are due on February 3rd. We have another speaker on February 20th that will feature Dr. Mark Boulos and Sarah Berger from Sunnybrook Health Sciences Center, and they'll be discussing their research on harnessing data from the Sunnybrook Sleep Laboratory. If you aren't already a T-CAIREM member, you can join us by visiting our website for eligibility requirements. And don't forget to follow T-CAIREM on LinkedIn. We're now one of the biggest AI and medicine networks in the world, and we want you to be a part of it. Have a good afternoon, everyone. Have a nice weekend, and thank you so much for joining us today.